The final simplex tableau is obtained when no more pivoting can be completed. That means that in the final row there are no negative values. So once we have a matrix that looks like this, with no negative values in the last row, the variables corresponding to the columns in this table that look like the identity matrix are called basic variables. So what that means is that x1 is a basic variable because it has a 1 in the x1 spot, zeros elsewhere. x3 is a basic variable because it has a 1 here, zeros elsewhere in the column. s2 is a basic variable because it has a 1 and zeros elsewhere. And z is a basic variable because it has zeros in the first 3 rows and 1 in the final row. So in this example, the basic variables are x1, x3, s2, and z. And the other variables are non-basic variables. So x2, s1, and s3 are non-basic in this case. And just note that in this case, the columns alternate between basic and non-basic. That is just coincidental. Just for this specific problem, that won't always happen. But the non-basic variables, we see them as the columns where the entries are not just ones and zeros, as the basic variable columns are. So something interesting happens with the non-basic variables. If we take the final row and we turn it back into an equation, it would be 5 times x2 plus 1 times s1 plus 1 times s3 plus 1 times z equals 220. Or if we rewrite it how an objective function is normally written with z on one side, the other variables on the other, we would subtract all the other variables to get 220 minus 5x2 minus s1 minus s3. And since our goal with the simplex method is to maximize z, all of these variables x2, s1, and s3 must be equal to 0, and the maximum value of z is going to be 220. So this is because we know that x2, s1, s3, all of the variables are non-negative. So if we're subtracting a non-negative number and we're trying to maximize the quantity z, we would hope that we're subtracting nothing at all, or that these 3 variables are 0, which is the case. So that means that the non-basic variables here are going to be equal to 0. So x2 is equal to s1 is equal to s3. All of those are 0. And now we can find all of the other variables for the optimal solution as well. So if we turn this first row into an equation again, that would be x1 plus 2x2 plus 3s1 minus s3 equals 100. But we know that x2, s1, and s3 are 0. So this is 0, 0, 0. And we just get that x1 is equal to 100. Now taking the middle row, would be negative x2 plus 5s1 plus 1s2 plus 1s3 equals 50. And again, we know that x2 is 0, s1 is 0, and s3 is 0. So this one's 0, this one's 0, this one's 0. And we get that s2 is equal to 50. And last, we take the third row and change it back into an equation. So negative 3x2 plus 1x3 minus 7s1 plus 2s3 equals 60. And again, x2 is 0, s1 is 0, and s3 is 0. So from this equation, we get that x3 is equal to 60. So what that means is that our optimal solution, or our maximized solution, is z equals to 220, and it occurs when x1 is equal to 100, x2 is equal to 0, and x3 is equal to 60.